This video is going to cover Unit 30, Section 3. Volumes and surface areas of composite solid figures. So we're going to be adding up several pieces together and finding the volumes and surface areas. So the picture there on page 741, figure 30-7, shows a bunch of pieces that you have to find the surface area and the volume of. Now what it is just two rectangles and a triangle welded together, but there's a significant number of rectangles that you have to add up. That one's not necessarily too difficult, but it's extremely tedious. What I want to look at is on page 746, number 16, figure 30-21. First, I want to take a look at this one. Okay, so what we have here is this figure right here. Compute the number of cubic yards of concrete required for 3-inch thick concrete patio. Okay, so here's the situation with this one. What I have here is all of my dimensions are given to me in feet, except for that it is 3 inches in depth. Okay? Then what I need to do is calculate the number of cubic yards. So there is some unit stuff that we need to take care of with this. So first thing that I would do is I would calculate, I would not convert the inches into feet, although you could do that. But what I would do is I would convert all of these feet into inches. That's the method that I would use. But I guess if I was going to convert this into feet, it would be 3/12, which would be 1/4. So this would be 1/4 of a foot, or 0.25. I guess we could do it that way. I think that would probably be easier. So I changed my mind. So 3 inches is the same thing as saying 0.25 feet. So that's the depth. So what I'm going to do is I'm going to find the surface area, then multiply it by 0.25. All right? So what we have here is we have a rectangle here. We have a right triangle right here and a sector right here. So let's find the area of the sector first. So the area of the sector, that is equal to, remember, the degrees over 360. So I'm not going to write the initial equation. I'm just going to write the numbers in it. 120 over 360 times the area of a circle. So that would be pi, so 3.14, times the radius, which in this case, the radius is 15 feet. Okay? 15 feet. 15, and that's r squared. So right there. So this will give me the area of this sector right there. So let's find that. And this is probably the harder area to find. That's why I'm doing it first. I like to get the hard stuff over with. 120 over 360 times 3.14 times 15 squared, and the area is 235.5. And of course the unit on that would be square feet or feet squared. Now let's find the area of the triangle. And that is base times height divided by 2. So let's take, this is the base is 26, and the height is the radius right here, which we know to be 15. So 15, or 26, doesn't matter which number comes first. 26 times 15 divided by 2. So 15 times 15, 195. 195 feet squared. So there's one important number. There's another. Now we need to find the area of that rectangle, which is going to be so I need to find the distance from here to here. Well, I've got this distance from here to here. How would I find this distance from here to here? There's a right triangle right there. So we'll just call this distance, for D for distance. So to find that, I need to use the Pythagorean theorem. Okay, so that is going to be distance is equal to, okay, what are my dimensions here? 15 squared plus 26 squared. I'm using the right triangle and then the square root of that. The square root of 15 squared plus 26 squared equals 30. We'll just cut that to, we'll just simplify that to 30. Close enough. So, now that means that the distance from here to here is 30 plus 15, which we know to be 45. So 45 times 12. That'll give us the area of, oops, off the camera, sorry. (45 times 12 equals 540. So 540 feet squared. So now I add all of these up. Plus 195 plus 235.5. So the surface area of this figure is 970.5 feet squared. Now, to find the volume in feet, we take this number and we multiply it by 0.25. So we multiply that by the height. And that volume will be times 0.25 equals, the volume is equal to 242.625 feet cubed. So that's the volume in feet cubed. Well, they want cubic yards. So how do we take care of that problem? So we have to understand how many cubic feet there are in a cubic yard. So we go back to, let's go up here, right in that spot. I got a spot, I can do this. So remember, we've got 3 dimensions. 1 yard is 3 feet. And another yard is 3 feet. So that gives us square. So we could find out how many square feet there are in a square yard, but we need cubes, so we need 1 more. So we need to find out what 3 times 3 times 3 is. So 3 cubed is equal to 27. So 27 yards cubed is equal to 27. Oop, I did that wrong, didn't I? Ignore that. 1 yard cubed is 27 feet cubed. So what I need to do is I need to multiply that by, so I have feet cubed here. I need to put my feet cubed up here. So 242.625. And that's feet cubed. I don't want to get too far over here. So the feet cubed and the feet cubed cancel out. And let's just put a 1 there just as a placeholder. So 1 times that, and then 27 times 1. So basically, I take 242.625 and divide that by 27. 242.625 divided by 27. That gives me 9. 9 yards cubed for that whole thing. So you could order 9 cubic yards of concrete, and you'd be safe to make sure that all that got filled in, because that was rounded up just a little bit. And that's the way I would do it. I would round it up a little bit just to make sure that you've got enough. Because if you round down and you don't have enough, and you've got your frame all in, and then they pour the concrete in there, and it doesn't come up high enough, well, then you got a problem, because you should have a continuous pour in this thing. Because if you stop and then you order more concrete and pour it on top of it, it's just going to make it weak. Ta-da! Now, the other figure I want to look at here for this stuff is on page 745 at the top, figure 30-15. And the only thing they want is the capacity. We're just looking for the volume here again. We're not looking for surface area on this. But we could find the surface area. So, ignoring all of this stuff, we have room to write all this in. So what I have is, I've got a, let's see, make sure I did that right. So I've got a frustum up here that I need to find the volume of, and a cylinder that I need to find the volume of. Now let's take a look at the units. They're asking for liters, and we are given centimeters. Okay, we'll deal with that at the end, but we need to be aware that we need to deal with that. Remember, a cubic centimeter is a milliliter, and there's 1,000 milliliters in a liter. Okay, we'll deal with all of that when we come to it. So the volume of, we'll do the frustum first, because it's the hardest thing. So, let's see, there's room down here. Volume is equal to 3.14 times the height slant. Height slant, what about that? Remember now, the height slant is this distance from here to here. No, we're doing volume. Skip it, we're doing volume. Height. See, my mind gets twisted like that sometimes. So it's simpler even. We don't even need to do the slant height. Yeah, I make mistakes. I'm not even going to edit that one out. I'm too tired of editing. Okay, so multiply that by the big radius squared, and the big radius squared is right in here. The diameter is that, so the radius is going to be 11.2, and then we'll square that, plus the little radius squared. This is 4 centimeters is the diameter, so that's just going to be 2 squared. I'll go ahead and write it as 2 squared. And add to that 11, so it's radius times radius. 11.2 times 2. And then all of that divided by 3. So we'll find the volume of that. .14 times 16 times parentheses 11.2 squared plus 4 plus 11.2 times 2, and then 3 in the denominator. That gives me this volume as okay. 2,542.8 centimeters cubed. Now the volume of the cylinder is going to be the base times the height. And the base is pi 3.14 r squared, which is 11.2 squared, times the height, which is 20. So 3.14 times 11.2 squared up times 20 . 7,877.6. So I add this to this. So 2542.8 plus 7877. Too many sevens. So my total volume, I'll put it right down here. Total volume is 10,420.4 milliliters. Remember I said cubic centimeters is the same thing as milliliters. Now there's 1,000 milliliters in 1 liter. So let's see. Running out of room. I should have planned this a little bit better. So the unit I want to leave is liter, so I'm going to put that in the top. 1 liter is 1,000 milliliters. Multiply that by this number right there. So basically what I have to do is I have to take this number and divide it by 1,000. So instead of trying to cram that in there, that's just what we're going to do. So I already have it in there, so I divide that by 1,000. So the volume of this figure is 10.4 liters. Just a little bit more than 5 2 liters. Okay, on page 744, number 8, figure 30-13. All right. So what we need to do here is we need to find the volume of this figure, and then we need to find out what the weight of this thing is. Because the weight of this steel that is used is, I'll write it right over here, 490 pounds per 1 cubic foot. So foot cubed. So let's look at our units. We have all of our units here are in inches. This is the depth, by the way. I didn't try to draw it three-dimensionally the way they have it, so I just stuck the depth down here. It's 2 inches deep. For the 4 smaller holes, oh, that one didn't come out right, but the 4 smaller holes are 1.5 inches in diameter, and the larger hole in the center is 3.2. Both of the edges are 14 inches. So what we need to do is we need to find the volume of this entire figure. So the first thing that I'm going to do is find the volume in inches squared. Then we'll convert that to feet squared later, of the whole block if it was completely full. So that volume will equal the width times the length. So 14. You could write it as 14 times 14 or 14 squared, it doesn't matter, and then times 2. So that will get me the volume of the entire square as if the holes were not drilled, and then we'll subtract those out. So 14 times 2 is 392 inches cubed. Important number. Okay, now let's find the volume of the center circle. So the volume of that will be it's like taking out a cylinder. It is taking out a cylinder. It's not like taking out a cylinder. Now we got to find the volume of this cylinder right here. So the radius, I'm going to need the radius. So 3.2 divided by 2 is 1.6. I'll just write that right there. 1.6 R. Okay, so it would be the base times the height. And the base is going to be 3.14 times the radius squared, 1.6 squared, times the height, which is 2. And that will give me the volume of the center cylinder. So 3.14 pi times 1.6 squared times 2, 16. 16.1 inches cubed. So there's another right there, important number. Now I need to find the volume of the small cylinders. Find the radius first, 0.75. So 0.75 is the radius. I'm just going to point to one of them. All 4 of them are that. So if I find one of these, I just simply multiply that by 4 to get all of them. Times 2. So find that one. So 3.5. 3.5. I didn't really cover significant figures. It really wasn't part of the class. Maybe I will in a future class. So if you take it again, oh, I need to multiply that by 4. I will multiply it by 4 before the rounding. And then round it. Okay, so multiply that by 4, and I did it before rounding, so it's 14.13 inches cubed. So I'm just going to cross this off so I don't confuse myself with that. Not like that could happen. So to find the volume of this figure, and now instead of adding, I need to subtract. So I need to take this number, because that's the total volume. I need to subtract this number and then this number. And then we will have the volume of all of the steel in that in cubic inches. So 392 minus 16.1 minus 14.13 is, and I am not even going to round this one. There's enough rounding involved. So the volume is equal to 361.77 inches cubed. Now I need to convert that into feet cubed. Or actually, I can just convert it right straight to pounds from feet cubed. Yeah. So what I'm going to do is say 490 pounds. Now that's the reason why I'm putting that in the top, because that's what I need. And this is per foot cubed. Now I'm going to multiply this times, I need foot cubed in the top and inches cubed in the bottom. Now, this is not this inches cubed. We need to figure out how many inches cubed there is in a foot cubed. So we'll come down here, 1 foot. This is the best way you can do this. 1 foot is 12 inches. Another foot's 12. And then another foot is 12. So this helps you visualize kind of what's going on. Now you may memorize, maybe, how many inches cubed there is in a foot cubed, and that's fine, but you might not want to try it. I mean, someday it might just come to you anyway, because if you use it often enough. So what I have is 1 foot cubed is 1,728 inches cubed. Now, I have not yet done 3 of these in a row, but I'm going to. Okay, so now inches cubed is in the denominator. I need inches cubed in the numerator. And I have this figure right here, which is 361.77. And I'm just going to put a 1 here just as a placeholder. So now let's look at what's happening here. I could have went ahead and done this conversion and found out how many cubic feet this is right here, and then did this conversion to find out how many pounds it was. But since my final answer needs to be in pounds, I just set this ratio up right here because this is what they give me. And then this is the ratio that tells me how many inches cubed are in a foot cubed, and then this is what I have for how many inches I have. So the units are going to cancel out that I don't want, which are going to be feet cubed and feet cubed, and then inches cubed and inches cubed. All right? The only unit I have left is pounds, and that's what the answer is looking for, which is why I specifically put it in the numerator to start with. So we multiply across the top, and there's only this in the bottom, so once I multiply across the top, I will divide it by that 1728 28. So 490 times 361.77 equals that. Divide that by 1728, and I get that seems kind of high. 102.6 pounds. Yep. After doing some other calculations, that makes sense.